Hello. Thank you for the kind introduction, Diana. Now that we've all established that I'm an alcoholic, I hope that we have all lowered the expectations for the talk. So, my name is Ciprian Caba. I'm currently unemployed, and I'm going to talk to you about JavaScript. I have the very difficult task of representing tim.js, which is an amazing community that's been going on for I think it's more than 10 years now. Very consistent, very hard work from the local community. Really proud to be part of that. And yeah, if you are from around, make sure to check out the meetups. So I'm also not very young. I'm kind of old. And back when I was young, we called websites websites. And life was rather simple. You had a browser that made a request to a server. The server would return an HTML. The browser would render the HTML. And everybody was kind of happy. But then it turned out that people didn't really like static data. So we had to do dynamic rendering, dynamic pages, render data from a database, and all that stuff. So now when the browser would make a request to the server would call a database, get some data, and then render the HTML with the dynamic page, which was amazing. And also there was a way to interact with the page by submitting forms or submitting forms. So that was good for a while. People kind of could interact with the data, change the data, everything was kind of fine. Now we call those applications multi-page apps, but it turns out that people actually really like interactivity. So that wasn't enough. So we had to put our minds to come with something great, something so good that is going to allow immediate interaction with the website and immediate interaction with your server. So what we ended up doing, we changed this initial interaction from the browser to the server to return an empty HTML that contains a link to a JavaScript file. Then we would load that file, send it back to the front end. The browser would have to parse that file and start loading data from the server that would go to the database and then come back to the front end, and then start rendering HTML from the browser itself. So if this seems a bit convoluted, like the main benefit of this was that obviously, all the interactions you would do with the page are now controlled by the front end. You would be able to make changes in the DOM immediately based on the responses from the server. You could change just parts of the DOM. You wouldn't have to reload the entire page. So that was really good. We stuck with this for a while. It was great. We kind of started calling this app server bit like the REST API or the server or whatever you want to call it. But mostly, yeah, REST API was the way to do backend. And REST APIs are great. Like they're very simple as a concept. Like you just do CRUD operations. You can create resources, read them, update them, delete them. It's amazing. And then it's also stateless, which means that all the requests that you're doing kind of need to have all the context for your request to actually do the action it needs to do, which is amazing because it allows scalability at a level that was unseen before. And then you can have all these services that are written in different languages. It doesn't matter because you talk through an API. So you would use JSON to communicate information from your server to the front end, and then the front end would just work with like PHP in the back end, with Python, with Ruby. It doesn't really matter. And then caching became really easy because you would just cache a request. Browsers understood caching. Life was really good. We did something great. So let me tell you a story. A couple of months ago, our logistics partner came and said that they need to make some changes to the API. But basically, it's just going to be like something that we need to change the URL, and then it's still going to work. So we said, OK, but do you have like any documentation for the stuff that changed or whatever? They said, OK, here's a PDF with the documentation. So when you get the documentation for an API in a PDF file, you just know it's going to be an amazing API, and it's going to be great. What can go wrong? And then later on, we got an email saying that, hey, we've made some amendments to the API call, so there might be a bit more work involved. Okay, do you have some documentations for that? And then they said, yeah, check the network tab. It's this really powerful tool where you can see all the requests that are sent from this dashboard that we build. You can see what params you need to send, and then you get the response, and then you can figure it out from there. Like, yeah, that works. Also, we need to end this by the end of the month. So I said, okay, interesting. So let's see. Basically, as an e-commerce platform, we had to create an order, and then the warehouse would fulfill that order. So it was very easy. Like, you just post a request to the credentials API with your username and password, and then you would post another request to the orders endpoint to actually create the order. So that was good. But then we also had to notify our users when an order was shipped and when the status of that shipment changed. So, okay, let's retrieve an order status. So in the previous API, we just had one call to an endpoint that was called shipments that would return the shipment number, the shipment status, and the order ID, which was great. In this new improved API, we actually had the same endpoint, and I don't know if you can really see it, but I spent a couple of hours debugging why this get endpoint on the shipments wasn't working. And then I remember about the network tab, so I went and checked that in the dashboard, and it turns out it was actually a put request to get the shipments, which makes a lot of sense, right? So you would get the shipment, but the shipment would just contain some very superficial information regarding the shipment. And you would have to use the same shipment ID to make another request to another endpoint to get the actual order ID. And then based on the order ID, you would make another request where you get the order information. And then because the information on the shipment was just shallow initially, you would make another request to another shipment endpoint to get all the information and the tracking URL. So that was a mess. So what have we seen here? Like, the REST APIs kind of suggest a standard, but they don't really enforce it. So then it's the Wild West out there. Like, you can do whatever you want. I'm pretty sure like everyone had to work with some less than optimal REST APIs. And then we had this problem with over and under fetching. So in order to get just the tracking URL from a shipment and the order ID, I had to make like 3 different requests per shipment. Like, that just doesn't really make sense. And then for each of these, I had to make all these round trips from the front end to the server, get all this information, use the information to make the next call, and so on and so forth. This created like a waterfall effect. And then, yeah, REST APIs also don't offer any real-time support. So that's when the pandemic hit. Like, we were kind of set on single-page applications, we were set on REST APIs, everything was amazing. They weren't perfect, but they did the job. So we started scaling our backends by creating microservices and other microservices and microservices and another microservice, and so on and so forth. And depending on how big your company is, you would just add more microservices to make everything scale. So this is basically virtually infinite. But what does this mean for the front-end developer now? Like, you need to get data from each and single one of these microservices, load it, and then transform the data into HTML. So this looks maybe something like this. This is an oversimplification, obviously. But yeah, the micro-pandemic hit hard. But okay, let's see what would an ideal case be for a front-end application. Like, what do we want to do with the web app? So ideally, we would communicate with a single API. We would make one single round trip to the API. We would be able to support multiple microservices, just have like one authentication layer. We kind of want versioning that doesn't suck, or maybe no versioning at all. And then ideally, we want to use type safety and code generation to avoid using tests, for example. Built-in, up-to-date documentation would be amazing, so we don't pass PDFs around. And then if there is some real-time support, that's really good. So the good people at Facebook, because they faced all these problems, they came up with this new API, which is GraphQL, which is really amazing. So it kind of solves a lot of these problems, because now you just make one request to the GraphQL API, the front end gets just the information it needs, and it's really simple, right? We've simplified our app. We can interact with the page, we can create a mutation in GraphQL, everything is great. We fixed web apps. This is the way. But then if you think about it, what does the GraphQL endpoint do? It's just like a proxy to your old friends, the microservices. They're still there. And it kind of helped fix the problem from the front-end side, but moved the problem just to the back-end layer, which is the GraphQL layer that would still have to aggregate data from all these sources and make sense of it. And GraphQL doesn't come for free. Like, code generation is great, but it's not as easy as it seems in practice. Type generation usually generates some really weird types that are really scary. Syncing data from multiple sources is still a problem. And then caching is a bit more problematic than REST APIs, because all requests in GraphQL are just a post request, and it's just a bit more difficult to figure out what to cache. And then you need to learn GraphQL. Nested queries are still problematic, because in GraphQL it's really easy to request like multiple layers of indirection of data, and then your backend coworkers won't be very happy about that. And it doesn't really cure the micro-pandemic, it kind of encourages the micro-pandemic, because GraphQL is a very nice layer between your front end and your back end, and it kind of just works, so it kind of encourages you to write microservices. Okay, let's take a step back. So we went from this, which was just making a request, getting back the HTML, and rendering a page, to this, or like the GraphQL version. So we need to ask ourselves, like, what should the web app actually do? In its most basic form, we want to pass the data from the database to the user. We want to allow the user to interact with the data. We want to use the database for storing data, because it's the place that makes most sense. We want the browser to render HTML data, because this is what it was built to do. We want to offer a great user and developer experience, right? So how can we achieve all these things? Well, welcome to the framework. So most of the frameworks these days are kind of converging towards a single goal, where they kind of simplify all this interaction from the front end to the back end data. And depending on which side of the web development you're coming from. So if you come from the front end, you'll have like lots of modern frameworks that are doing an amazing job. If you come more from the back-end side with more templating languages and things like that, like there's HTMX, but I'm not here to talk about any of these frameworks. I'm here to talk about the ideas behind these frameworks and the trend towards where these frameworks are converging. So welcome to the future. So the future is currently static site generation, incremental static regeneration, and server-side rendering. So what does that mean? It means that when you make a request to a server, you get the HTML back, and then if you need your front end to be interactive, you simply load the JavaScript that's needed to make that interaction possible. So why would we ship an entire bundle of JavaScript that's capable of rendering the entire website instead of just shipping the JavaScript that we need for a specific page in a specific context? Well, I don't know. We just thought it was a good idea. So how does static site generation actually work? It's very simple. Your HTMLs are built at build time, so when you make a new deployment, your framework will go and generate all these HTML files for all your pages. Now, the problem with this is obviously that the data is going to be static at the point of build time, and there's not really that much interaction that you can do, but you can still load JavaScript bundles, allow parts of interactivity, and then from a static generated HTML file, hydrate it and do whatever you need with it. In terms of incremental static regeneration, kind of works the same way, but the HTML is no longer generated when you build your website, it's generated when you actually access your website. So when you go to a page, that page is going to get generated on the fly. However, if the page was already generated by a previous request, the framework would cache that HTML and it would serve you the cached version of the actual site. So again, interaction is still possible because you just ship the JavaScript that you need in the context that you needed. And then server-side rendering is probably the more correct and generic name for this entire technique of rendering websites, where like most of the requests are just going to the server, getting the runtime generated HTML. It's mostly the same thing as ISR, but you are thinking about this in the context of like more, I don't know, particular cases like the user profile page or stuff like that, where you cannot really cache that because you wouldn't want a profile page from a specific user to be served to a different user, so you need to put a bit more thinking into the context itself. So what does server-side rendering enable? Basically, the browser will now mostly deal with HTML. Optimization is kind of done for you out of the box because when you ship a website or a page or a web app or whatever you want to call it, you would just ship the HTML that's going to render that page, but it's not going to ship all the code that was used to generate that page. So as Anna was mentioning yesterday, when she had a problem with the big React icons library, that would never happen in the case of server-side rendering because you would just ship the actual icon that you used to generate the HTML. Because now you can actually cache HTML and you don't have to think about JSON. So instead of sending all this JSON from your APIs to your front end in order to render like maybe one very small component, you just send the HTML directly. So then you also have a great user experience and developer experience because you can actually go and check your HTML, see what it's made of. Like it's much simpler than just getting back an empty HTML, and it's also very fast because browsers can actually render HTML. And then the crawler bots are happier than usual because they don't have to do an extra step to download their JavaScript, parse the JavaScript, run it, and make it work. So let's focus on this bit here. So cache HTML instead of JSON. So this means that when you go to a website and you make a request to a page, you usually need to aggregate data from all these microservices or from all these different data sources. So the result of that is just an HTML file that is the actual page that the user sees. So imagine going to an About Us page, for example, where you have a React app that needs to render like something that's very static, but it's coming from a REST API, the content. So every single user would still have to make the request to your server, get served that empty HTML file, including the JavaScript bundle for the entire website, and then just render a piece of static content. Like, does that really make sense? Not really. If you make this request on the server side, you can just cache the result of this About Us page, and then every time that someone requests that page, you can already serve it because it was already compiled for another user, maybe. So in terms of like how this would look, the first example is, for example, the list of shipments for an HTML page. And then the example here in the right would be maybe the data that you need to generate this HTML. So the point I'm trying to make here is that maybe you don't need to call your API straight from the front end. Maybe the server can deal with that. The server is closer to your database. It's going to be much faster. If it needs to make multiple requests, the requests are going to be faster. So just cache the HTML and use server-side rendering where possible. Like from this JSON here, like it doesn't really matter what it says. It's just like a big convoluted file. Like I just need these 3 lines. Like why would I transfer all this data across the line? So where does that actually leave us? We are at a point where the modern frameworks have become like really good, and you don't really need maybe the the proxy that the GraphQL was to aggregate this data from your microservices. The framework acts as the gateway for the user to interact with your database. So this happens like through various different implementations, obviously, that are specific to each framework. But for example, in React, you have React Server components where you can basically fetch data from the microservices, render the HTML, and then they're very similar to what you would do on the front end. It's just all on the back end. You can cache the output of that component, and then everything is going to be great. But then going back again and taking another step back and thinking like how you actually interact with your data, you start thinking like, if the framework is doing all the requests to your backend, is there even a need for the API? So those of you that use React might know Dan Abramov. This is obviously out of context because I wanted to make a point, but he did tweet this at some point: never write another API. So obviously, like if your product is the API, like you would write the API. But if you do it, like just write it in a proper way. But maybe like for smaller apps or like for apps that just aggregate data from, I don't know, where it's easier to just go directly to the database instead of calling an API, I mean, maybe just take a step back and ask yourself if you really need that API, because if you can access the database straight from your framework, then what's the point of the API anymore? So this would greatly simplify your application infrastructure, and it's going to make things a bit easier. So I guess what I'm trying to say is use the framework. Don't be afraid to use the framework. You can use JavaScript everywhere. Even better, you can use TypeScript everywhere. We are in a very privileged position as JavaScript engineers because we literally write JavaScript on both the front end and the back end, and it's just something that you would never be able to do in Python or PHP or Ruby. Yeah, you can share the data model from your backend to your front end. Like, I'm sure you've had this problem before where you had a data model that was working on the backend, and then the front end would try to make sense, and they would just be out of sync, basically, and that can cause like a lot of problems, issues. You can obviously share validation and business logic. Probably one of the more interesting things is that you could now take end-to-end ownership to build features. Like, you don't have to wait for the backend team to build this new API endpoint. You don't have to wait for them to create another optimized endpoint for your specific use case. Like, you can just go there and build it yourself, because working with a database is not that scary. And then this also enables atomic deployments. So an atomic deployment is when you deploy your front end and back end at the same time. So instead of having to deal with different versions in different parts of your system, you would just make one deployment that would allow you to be confident that the functionality is not going to be out of sync. So at the end, I just want to show you like a simple example to make the point I'm trying to make. So on the left, you have a Prisma schema. So Prisma is an ORM. It allows you to interact with your database in a very simple way. So you could potentially define a user model, an article model, and here on the right, this is just a React component, but it's actually a React server component. Like, you might notice on line 4 that we have an async. And that async actually doesn't work on the client side, but it works on the server side. And you don't need an API to query your data from your database because Prisma is already doing it for you. So you can use this query to select all the articles and select the name of the author. And then here, when you're trying to display the actual author for an article, you have this amazing code completion that's always going to be in sync with your model, and then Prisma is going to take care of like generating migrations for you or generating the types. So there's no messing around. It just works. But yeah, what are some takeaways? Like I've gave you a lot of information. Like I'm not trying to say that GraphQL is a better API than REST APIs. It does give you some advantages, but your mileage may vary, obviously. Like in some cases, you can use one or the other. It doesn't really matter. Server-side rendering, again, it's amazing if you think about it, but you have to think about this like from your own perspective. Like, would it be able to help you? Like, I've heard some situations where you would need to download an app and then just re-render HTML on the fly. Like, for that use case where you are offline, server-side rendering obviously doesn't work, but maybe a React app would work because it can generate the HTML without connecting to the internet. So probably the more important takeaways would be the motto of this conference. So just think about the things you are doing and maybe see if there's a better way of doing them. Like revisit all patterns like server-side rendering. Server-side rendering is not something new. It's something that PHP used since the beginning. Like this is how all the websites worked initially, but then we just decided that that doesn't work for us anymore because we want the rich interaction. And then, yeah, take all these takeaways and evolve, or even better, revolve. So, yeah. Yeah, I guess the beer is more like a metaphor for having a nice interaction around conferences around the world. You don't have to take it literally. Like, I'm not encouraging in any way, shape, or form the consumption of alcoholic drinks, obviously, but do interact with the speakers. Like, they're all eager to bounce ideas and, yeah, rethink, revisit, and revolve. Thank you very much.